Welcome back, everyone, to another deep dive.
Always fun to dive in.
Today we're going to be looking at how AI learns to recognize images.
Okay.
Specifically, a really interesting new twist on something called self-supervised learning. And I think, a lot of our listeners probably are familiar with that term. But basically, think of it as AI teaching itself without needing us humans to hand label every single image.
Right.
It's kind of like if you imagine learning about different kinds of trees, but you just watch, tons of nature documentaries.
Yeah, that's a good analogy, actually. Self-supervised learning is all about letting AI kind of loose on all this massive amount of data that already exists out there, rather than us having to carefully curate it and categorize everything for it.
Right, exactly. And so leading the charge in this area is this family of AI models called DINO and DINOv2. And these models are already making waves. They're really shaking things up in image recognition. But they've always been a bit complex and kind of finicky to work with.
Yeah, you're right. They've been a challenge for wider adoption just because of how much fine-tuning and, specialized knowledge they require.
Right. So that's what's so exciting about the research that we're going to be diving into today, is it tackles this head on.
Mm.
Researchers have found a way to simplify DINO, make it more stable, make it easier to use. But here's the kicker. It also performs even better than the original. It's kind of like if you took a really powerful but complicated recipe and you were able to streamline it, and somehow it tastes even more amazing.
That's a great analogy. It's really fascinating to see. To really appreciate this simplification, I think we need to understand a little bit about how DINO works in the first place.
Okay, let's break it down.
Yeah.
So DINO basically learns by looking at multiple views of the same image. So imagine, you take a photo of a sunflower, but you take it from a couple different angles. Maybe the lighting's a little bit different.
Right.
DINO takes those variations and tries to create a consistent representation of what a sunflower is, even though those views are different.
Right. And it does this using two key parts: a teacher network and a student network.
Okay.
Think of it like an apprenticeship. The student network is learning by observing the teacher network, which acts as a guide. And the teacher network is in turn constantly being updated by what the student is learning.
Interesting. So it's like a dynamic.
It's a feedback loop.
Oh, that's cool. But like any learning process, things can go wrong.
Yeah.
One challenge that DINO faces is something called representation collapse.
Yeah, this is where the model essentially gets stuck. And it starts treating all images as the same. It's like forgetting that a sunflower and a rose are distinct types of flowers and just, lumping them together as things with petals.
Right.
The original DINO had a bunch of complex mechanisms to prevent this, which, as we said, made it more difficult to work with.
Right. So how did researchers manage to simplify DINO and prevent this collapse at the same time? What's the secret sauce?
They actually added something called a coding rate regularizer to DINO's learning process. This new component explicitly encourages the model to learn diverse representations. So instead of just saying, things with petals, it's pushed to recognize the unique features of each flower.
Okay, so it's not just about making DINO simpler. It's about making it smarter in how it learns.
Exactly, and the results are quite impressive.
Well, I'm definitely intrigued. Let's hear more about what this simplified version of DINO called SimDINO can actually do, and how it compares to the original.
Sounds good. We'll delve into some specific examples and really break down the advantages of SimDINO next.
So we've talked about how DINO works and the basic idea behind simplifying it, but you mentioned there's also a DINOv2. What makes it different?
DINOv2 kind of took things a step further. Imagine going from recognizing a bird to understanding the subtle differences between a sparrow and a robin.
Right.
DINOv2 aimed to capture those finer details in images. It borrowed techniques from another model called iBot to achieve this.
Right, iBot. That sounds familiar. Wasn't that the one that would cover up parts of an image?
Yeah.
And make the AI guess what was missing?
Yes, that's called masking. DINOv2 adopted this approach, randomly hiding patches of an image and challenging the student network to predict what was hidden based on the surrounding context.
Okay.
This helped DINOv2 learn relationships between different parts of an image, leading to a more detailed understanding.
So DINOv2 was like Dino with a magnifying glass, but I'm guessing this also added a layer of complexity.
You got it. DINOv2, while powerful, inherited some of the complexities of both DINO and iBot. It needed extra layers for processing those finer details and still used some intricate mechanisms to avoid collapse.
And that's where SimDINOv2 comes in. Did they apply the same coding rate regularizer simplification to DINOv2 as well?
Precisely. SimDINOv2 streamlines DINOv2 by once again removing those extra layers and complex mechanisms. It relies on the coding rate term to keep the model from collapsing, and ensure it learns those diverse representations.
So it's a similar concept to SimDINO, but applied to the already more powerful DINOv2. What were the results like? Did this simplified version still manage to outperform the original labs?
The results were remarkable. SimDINOv2 not only matched, but often exceeded DINOv2's performance across a range of tasks. They tested it on image classification, object detection, and even video object segmentation.
Okay, those all sound pretty technical. What do those results actually mean for someone who isn't an AI researcher? How would these simplified models translate into real-world applications?
Let's take image classification. Imagine an app that automatically tags your photos. SimDINOv2 could power this, making it more accurate and efficient at recognizing different scenes and objects.
So my photo albums would be perfectly organized thanks to SimDINOv2. What about object detection? I've seen demos where AI outlines different objects in a scene. Could SimDINOv2 do that too?
Absolutely. Think of self-driving cars. They rely heavily on object detection to identify pedestrians, other cars, and obstacles. SimDINOv2 could help make those systems safer and more reliable.
Wow, that's a big deal. And you mentioned video object segmentation. Does that mean SimDINOv2 can track objects as they move? What would that be useful for?
Exactly. This has applications in everything from security camera analysis to movie special effects. Imagine being able to automatically track a character through a scene even as they move and the camera angle changes.
It's fascinating how these advancements in AI are impacting so many parts of our lives. But let's get back to the core of this research, this idea of simplification leading to better performance. Is this just a coincidence? Or is there something more going on here?
That's a great question. Why does simplifying these AI models seem to improve them? Is it just about efficiency? Or is there something deeper at play? To answer that, we need to think about the bigger picture of how we design and understand AI.
Okay, now I'm really curious. Let's dive into that. So we've seen that simplifying these DINO models makes them easier to use and, surprisingly, even more effective. But is there a deeper reason why less is more seems to work so well in AI?
It's a question that has intrigued thinkers for centuries. Can simplicity lead to a deeper understanding? In AI, we often assume that more complex means better, more layers, more calculations. But SimDINO and SimDINOv2 really challenge that assumption.
It's like those overly engineered contraptions that end up being more trouble than they're worth. Maybe some AI was getting too complicated, and SimDINO is a way to kind of get back to basics.
That's a good way to put it. By stripping away the unnecessary complexity, the researchers have revealed a more elegant core to these models. It's like removing the scaffolding from a finished building. The structure is stronger and clearer without it.
Yeah, but how does that simplicity translate into better performance? I understand it's easier to work with, but how does it actually make the AI better at recognizing images, for example?
One key factor is robustness. DINO and DINOv2 are quite sensitive to any changes in their settings. Even small tweaks could throw them off. But SimDINO and SimDINOv2, because they're simpler, they're far more robust, they can handle those variations without breaking a sweat, which makes them more reliable.
So it's like having a car that can handle any terrain. Smooth roads, bumpy trails, you name it. It's adaptable and less likely to break down when things get unpredictable. But there must be more to it than just being tough, right? How does being simpler actually make it better at recognizing those images?
Here's where it gets even more interesting. By simplifying the models, the researchers were able to gain a deeper understanding of how they learn what really makes them tick. And this allowed them to focus on the most important elements, leading to more efficient and accurate learning.
Okay, so it's like realizing that the secret to baking a cake isn't using the most exotic ingredients, but really understanding the basics of baking itself.
Exactly. And this deeper understanding can lead to even more progress. Now that researchers have a better grasp of the core principles at play, they can explore new ways to build on those, potentially leading to even more powerful AI systems.
So this is just the beginning then. SimDINO and SimDINOv2 aren't the finish line, but a starting point for even more innovation in AI.
Precisely. And the implications go beyond just image recognition. This idea of less is more could change how we approach AI development in many areas. Imagine AI that's not only more powerful, but also more transparent, easier to understand, and easier to control.
That's an exciting prospect. And it all starts with recognizing the power of simplicity, understanding that sometimes the most elegant solution is also the most effective. SimDINO and SimDINOv2 have shown us that less can truly be more in the world of AI.
As we navigate this rapidly evolving field of artificial intelligence, I think it's important to remember that complexity doesn't always equal progress. Sometimes the key to real innovation is stripping away the unnecessary and focusing on the fundamental principles that drive true understanding.
Well said. And with that thought-provoking note, we come to the end of our deep dive into the world of simplified AI. I don't know about you, but this has given me a lot to think about. I'm excited to see how this idea of less is more shapes the future of AI.
It's certainly a future worth pondering, and we encourage you, our listener, to continue exploring and discovering alongside us. Who knows what incredible breakthroughs await as we delve deeper into the fascinating world of artificial intelligence.
Until next time, keep those minds curious and stay tuned for more deep dives into the cutting edge of knowledge.